Hello, in this video we're going to set up a Lightning node using the LND implementation, and this is basically what we're going to build. So in order to connect to the Bitcoin network, we're going to need to use btcd. We're then going to set up a number of LND instances, all on the same machine, and then we interface with btcd and LNT using these components as well. In order to do this using Windows, you'll need VirtualBox to create an Ubuntu machine. You'll need Power ISO in order to mount your installation disk, and you'll also need the latest download of the Ubuntu desktop. This version worked for me, but as far as I'm aware, any previous version or later version will work as well. So once you've downloaded and installed all three pieces of software, we're then going to start up the VM VirtualBox. I'm going to create a new VirtualBox for our Ubuntu installation. So call it whatever you want, select Linux, Ubuntu will be automatically selected. I've then given it 2 GB of RAM, which is enough for the purposes of this test. We're going to create a virtual image, we're going to create the disk now, and we're going to make it a fixed size. So if you're using the testnet, you'll need about 30 GB of space. If you're using the live network, then you probably 150 to 200 gigs would be plenty. So we're going to wait for that partition to be created on the desktop. It will probably take quite a while, so I've just sped up the video a little bit here. That's created. We can then click on our new virtual machine, hit start, and we'll then be prompted to install a new operating system. So right click on the ISO you downloaded for Ubuntu, select Power ISO, and then mount it to whichever drive you've got set. So I've already got it mounted on F. So then we're going to hit start, and that will begin the Ubuntu installation process. So just follow the on-screen steps. It doesn't really matter what you use in terms of the machine name and the password, just follow the steps until it's complete. So now that the installation is complete, we're going to go back into Power ISO and we're going to unmount that drive so that it doesn't try and reinstall the operating system when we restart Ubuntu. So we're going to press enter and Ubuntu will start up for the first time. Just so that we can see what we're doing, we'll make it full screen. Excellent. So in order to open a terminal window in Ubuntu, you want to press Control, Alt and T, and that will bring up a window for us. And we want to make that just a little bit bigger so we can see what's going on. And then the first thing we want to do is install the Go programming language. So in order to do that, we want to add a new apt repository. We press enter to confirm that. We then want to update the apt list, which will just take a second. And then we're going to actually get and install Go language version 1.8. Okay, so Go language is installed. We're now going to, on our home directory, create a new folder called gocode, and this is where we're going to keep all our working files. And before we go any further, we're just going to do a little bit of configuration by typing nano.bashrc. This will load up a text editor, and the bashrc file basically executes every time you load up a terminal window. So we're going to add a comment go stuff, and then we're going to add export GOPATH and an export path variable. Now what this is doing in the background is it will allow you to simply type $GOPATH, and that will lead us straight to the gocode folder we've just created. So essentially it's a shorthand for us when we're typing, but the Go programming language itself needs to know where GoCode is for future reference. So Control and X will close that window, press yes to save changes, press yes to save it as bashrc. So we've closed down the terminal window and we've reopened a new window, and we're going to echo GOPATH just to make sure that that's worked correctly. And at any point you can type clear into the terminal window and it'll clear everything that's been put in there previously. So now we're installing Git from the default directory. It was already installed in this implementation, but it might take a second. And now we're going to go back to our home folder. Now, what we need to do that we've installed Git. So GitHub is where the repositories sit for the Lightning LND implementation, and there's also a couple of other bits and pieces that we'll pull down from GitHub to help us with this project. So what we're doing here is saying clone the LND implementation from GitHub and save a copy of that into our GOPATH, our Go source folder, into its own unique GitHub LND folder within our desktop machine. So that'll take a couple of seconds to download depending on how fast your connection is. And then once that's done, we'll tidy up the screen and we'll just browse into the LND folder where we've just saved the GitHub information. And from here we need to install something called glide. So we need to get that again from GitHub, and because we're not specifying a new folder, it will just install it straight into the folder we're in, which is the LND folder. And then we need to install glide. Which takes a couple of seconds. And then there is one final command, Go installation command, which we'll see in a second. I'm not quite sure what it does, to be perfectly honest, but it's needed to make everything work. And that's us done. So we've now installed the implementation of LND on our machine. So we'll clear that and we'll come back to it in a couple of minutes. So what we're going to do now is go back to our home drive and we're going to set up the Bitcoin interface. And in order to do that, we need to get a copy of btcd from roast beef. How many times have I typed that with it? Roast beef, but anyway, there we are. A roast beef folder in GitHub. And again, similar to the LND implementation, we're going to download that and install it onto our machine locally, or copy it onto our machine locally. And if I could type HTTPS correctly, that would help. Okay, and similar to before, we're going to go into the btcd folder, we're going to install glide, and then we're going to type in the go install command. So glide install, and then go install. Now at this point we've essentially copied the LND implementation and we've copied the btcd implementation, so we're now ready to actually spin up some of these implementations so that they start downloading the blockchain and starting up our LND nodes. So I'm not going to show it here in too much detail, but on the description below there's a number of commands you can key in to actually test your implementations of btcd and LND, just to validate that all the dependencies are there. So check the description below, browse to the folder that you've installed everything, as you can see here, and then run these commands and it will validate all of the implementations for you before you go any further. So once those are complete, let's just clear our screen so we can see what's going on. And the next thing we're going to do is spin up our Bitcoin node and start downloading the testnet blockchain. So we'll go back to our home folder and we will specify the testnet. You do need txindex activated, and then rpcuser and rpcpass. So once we spin up our node, in order to talk to that node, we need to specify a username and password, which is specified here. It can be anything you want. Obviously keep it simple for the purposes of testing. And then in a separate terminal, so Control-Alt-T again, we're going to query the node and see what it's doing. So in order to query the node, we need to use a separate command, which is btctl, specify it's on the testnet, specify our username and password, and then getinfo, which is a standard command used to get the status of the node. So what you can see here is the version it's running, but importantly for us is how many blocks have been processed. So if we load up web browser, Firefox, whatever you have, and what we're going to do is look at a block explorer for the testnet. So block cipher works. I actually use it later on in demonstration, or blockchain.info, the testnet version that works as well. So as you can see, we're quite far behind on the number of blocks that have been processed, but at the top you can actually see that we are processing thousands of blocks a second. So if you run getinfo again, you'll see the numbers increased, and we now just need to wait until the syncing with the testnet has complete, and this can take anywhere from an hour to, in my case, all day. So we've now swapped over to blockchain.info because block cipher wasn't working by the time everything had synced, and again we're going to query our testnet node to see what the status is. We can see the block number there, we can see it matches the explorers online, so we can be quite comfortable that actually we are now fully up to speed. So now what we're going to do is do some configuration before we get started. So we want to make, within our GOCode folder, a dev folder, and then within that dev folder we want to make 3 folders for our 3 LND nodes, Alice, Bob and Charlie. So we're going to now go into the Alice folder, and in this folder we're going to keep the database and all the information for a single node, and then we're going to replicate that for Bob and Charlie, so we have 3 nodes running on our local machine. So this is the command. It's quite long. You might want to just copy and paste it, change the password, the username and password details from the description. But what we're doing here is specifying that we want a new LND client listening to these ports that are mentioned there, set up on the, or in the folder called Alice. We want to specify no macrons, and we want to specify it's both the Bitcoin testnet and what Bitcoin node we're using as well. The macrons are used for verification and validation in the nodes. So if when you're running your btcd node you want to use macrons, you can do that in conjunction with the LND nodes, and I think it just gives you an extra layer of authentication, but it's not needed here. It's a little bit more complex, and it may be something you want to look into when running a node on the live service. So we've keyed in that command, and now what's happened is the LND node is saying, okay, I'm ready to start being a Lightning node, but I need some more information. I need a wallet, I need some addresses to base the LND node on. So before we create the wallet, we're going to do a little more work. So we're going to open up a new terminal window, and we'll use this to interface with the LND nodes. So in the second, where we create the Alice node, if you press Control-Shift-T or just click on the little plus icon, you'll create a new terminal window within this, so it just keeps things tidy. And within here, we're going to re-execute the same command as we did to spin up the Alice node, but we're going to do that this time changing the port numbers by 1, and that will create a separate instance of an LND node we'll call Bob, and that'll be listening on a separate set of ports. Press enter on that, and again it's now sitting there waiting for the wallet to be created, and we'll do the same again on Charlie. This time the nodes are number 3 at the end. Okay, so we have 3 Lightning nodes waiting for a wallet to become available before it can start doing its thing. So we're going to just make sure we're on our home screen. And again, we're going to go into the nano bashrc file again, come right down to the bottom where we added the Go stuff. And this time we're going to add 3 aliases within Ubuntu. So what these aliases are will allow us to type in shorthand commands into Alice, Bob and Charlie's LND window, and you'll see what I mean in a second. So rather than typing out everything in the parenthesis, LNC hyphen RPC server, etc., we will just be able to type LNCI hyphen Alice, and then the rest will be executed for us. So what we'll do with that is we'll duplicate that 3 times, 1 for Bob and 1 for Charlie, and then we'll simply change the name of the alias as well as the port that it's listening into. Now if you have any problems getting this up and running, just double check all your commands and your ports and make sure that you're definitely executing the command on the correct instance of the LND node or the Bitcoin node as well. So we then type in their source.bashrc, and that will just load those commands into our terminal so we can use them going forward. Okay, so now we'll switch into the GOPATH and we'll browse to the Alice folder. And finally, we're actually going to create the wallet. So we're in the Alice folder, the Alice LND node is spun up waiting for the wallet to be created. So if you type in that command lncli alice and then just press enter, it will give you a whole list of commands to say that it's been created successfully. And then we want to create the wallet by using the create command. Type in a username and password, sorry, just a password, has to be at least 8 characters. And once you do that, that will then create in the background, the LND node itself will create a wallet for you. It will encrypt that wallet with that password, and it will not create addresses for you just yet. So the wallet's there, and the node itself, which is that unique ID, is now downloading the rest of the Lightning Network and syncing itself with all the other clients. So that's just Alice so far. But before we go too much further, we're just going to create a Word document just to keep some of this information in. So we'll copy the public key and we'll save that. We'll then, same trick as before, Control-Shift-T, we'll create another terminal window. We'll go into the Bob's folder, and similar to what we've just done for Alice, we'll do lncli bob, create, enter in a password, it can be the same one as used for Alice, whatever's quick and easy for you to type. And again, if we do getinfo, now that happened because the LND node is still spinning up. It takes a couple of seconds. So if you get that error, just wait, try the command again, and this time Bob has now been issued on the Lightning Network with his unique identifier. So we'll save that as well. And then, as you guessed, we'll do the same for Charlie. So Control-Shift-T, go to Charlie folder, LNC Charlie, create, same password. Get an error because we were too hasty, get an error again because we were too hasty, but it works third time. And save a copy of the public key. So if you were a node on the Lightning Network, you could then at least identify that these nodes exist using these public keys. But obviously we need to open channels, which we'll do in a second, between the nodes in order for them to talk with one another. So we've created the LND node, we've created a wallet in the background, but we haven't created any addresses yet. So in order to do that, we use the new address command, hit enter, it'll have a think, and then it'll spit out a address. Now, these will look slightly different from the mainnet addresses. They'll start with a 2 if they're SegWit on the testnet. We'll do the same for Bob. And in order to open a channel, you do need some Bitcoin in order to put the initial transaction on the blockchain. But if you were just to receive a channel, so if someone else was opening a channel to you, you wouldn't necessarily need any Bitcoin to do that. It's only whoever's opening and closing the channel that actually needs the Bitcoin funds. So we will create those 3 addresses. Now I made a small mistake there and I actually created 2 addresses for Bob. I corrected it off camera, so going forward just assume we have Alice, Bob and Charlie all have their own Bitcoin addresses. So now that we've got addresses on the testnet, we go to the testnet faucet. There are a couple, pick whichever one you want. Paste in the address. And it is very slow because we're using the virtual machine. But what you want to do after verifying that you're human is simply claim for all 3 Bitcoin addresses some testnet funds. So that's us done for Alice. It will give you the transaction ID, but you don't need that just yet. Do the same for Bob. And then do the same for Charlie. Once you enter the details for Charlie, I'd recommend you click on the link to the transaction, because it's this link that will show you when your wallets have actually been funded. Now, what we've done there is create 3 unconfirmed transactions to add a balance to each of our wallets on each of our nodes, and you can see by typing in the wallet balance command that we actually do have, we can at least see the funds, but they're unconfirmed at the moment, so we're unable to spend them. So you can confirm that the faucet processes work correctly. We can also, at this point, type in list peers, and this will just show you a number of peers that your node has already found on the network and connected you to. You can type in list channels, and of course there are none, so even though you're connected to a peer, that doesn't mean that you've got any channels open. And another interesting command is get network info. It actually shows you how many nodes and how many channels and how much capacity the network has at the moment. So now we just need to wait for those transactions to complete before we can actually open any channels with each other. So while we're waiting for that transaction to complete, what I'm going to do is, if you select your public key for Bob and use connect the public key at localhost and then the port we specified previously, which will end in a 2, hit enter. That will then make sure that your node, your Charlie node, knows that Bob is on the network. Now, it does in the background, but being explicit by listing peers and connecting to peers helps later on. And then in the same way that we've connected Charlie to Bob, and Bob's node ends in that C0, we're now going to go into the Bob node and connect that to the Alice node. So essentially all three of our nodes are linked. Alice knows Bob, Bob knows Charlie, and there's a link between all three of them. So now if we do list peers, you see the original nodes that was connected automatically, and then Alice's node is also connected as well. So again, this is nothing to do with channels or payments. This is purely making sure that you have a peer on the network to be able to exchange information, download the latest version of the Lightning Network, and communicate with whoever that node is connected to as well. So now we're just going to wait for that balance to be confirmed before we move on to the next step of opening channels. So the transaction's confirmed as if by magic, and we also changed Blockchain Explorer. So now if I type in wallet balance, you'll see that it has actually been confirmed. Same with Bob. And same with Charlie. Okay, so now we have some Bitcoin, some Satoshi, in order to start opening channels. So in order to open channels, it's actually quite straightforward. We just use the same lncli alice command, and we list the channels we have at the moment to make sure nothing's open. So you can see there's nothing there. So we grab, again, Bob's public key. And this time, rather than connect to a peer, we're going to open a channel. We're going to specify that it's Bob we want to connect to by specifying his public key, and then how much value in Satoshi the channel will be. So we'll pick 1 million, and I would certainly recommend you make this as big as possible. What I would do is just make it 1 billion, find out what the maximum network amount is, and then use that. So for example, if the maximum network is 1.2 million, then use 1.2 million. It just means you've got more capacity for sending and receiving transactions with the other nodes. Obviously in real life, be very careful with how much you allocate to these channels, because if anything goes wrong, it can be lost. So we've opened up Alice to Bob. We're now doing it from Charlie to Bob. Okay, so once you've opened the channels, you'll be given a funding transaction ID. Copy that into whatever blockchain explorer you would like, hit enter, and it requires at least 3 confirmations. Now, when I done this, it just so happened that someone was spamming the blockchain on the testnet, so it confirmed almost immediately, but it usually takes about half an hour. So we've now got the channels. The channels have been set up. The transactions that initiated the channels have been set up. So what we're going to do is on Bob, on that LND node, we're going to create an invoice. And basically that transaction there is all of the information another node in the network needs to pay Bob some money. So in order to do that, we simply go into Alice's LND node, we send payment, and we specify the payment request that Bob's just generated. And that will use the one-hop link between Alice and Bob to make that payment. And we'll get confirmation that it's complete, how much the total value is for. So this time, if we actually list channels on Bob, we'll see this is a channel from Alice to Bob, which we've received that local balance of 10,001. So that's us made a one hop payment from Alice to Bob. So Bob requested the money and Alice paid. This time we're going to get Charlie to create an invoice. For a very small amount. And we're going to get Alice to pay Charlie. Now what will happen here is the money will be taken from Alice's channel with Bob, and then Bob will forward that money onto Charlie using the second channel that they've opened together. And that's what it's telling us here. So the first hop is that one from Alice to Bob. Bob charged 1 Satoshi fee. And then the second hop was from Bob to Alice. Sorry, Bob to Charlie. So that's a multi-hop payment. Now if we look at Charlie's channels, we'll see that Charlie only has one channel open, that's with Bob, and we'll see the receipt of the 123 Satoshi payment. Okay, so within our three little nodes, we have connected all three via the two hops, and we made a payment from Alice to Charlie. Now what we're going to do is go online to the Lightning faucet, and we're going to take that public ID and key, and we're going to connect to the outside world, basically. So exactly in the same way as we did for connecting our nodes together, the first thing we're going to do is connect them as peers using the connect command. Now this only needs the public, this needs a public key, and it needs the IP address and potentially port number of the node you're connecting to. So now if we list peers, you'll see at the top, the one ending in EE, we're now connected as a peer, not as a channel, just as a peer to the Lightning faucet. So now what we are going to do is open a channel with the outside world. So similar to what we did in the past, Alice open channel, specify who we're opening the channel to using their public ID, and then how much the value of the channel will be. So again, 100,000. Now, push amount is interesting. If you set up a channel for 100 Satoshi, but you want to give the other person 50 Satoshi so you can transact with one of each other, sort of an initial funding, then you use the push amount. So we've set that channel up, we've waited for 3 confirmations. So now on Alice, because it's only Alice that can talk to the outside world, if we type in list channels, we'll see this brand new one that's been opened with the outside world, with the faucet that ends in EE for the amount we specified. So we now have a bridge from Charlie to Bob, from Bob to Alice, and then Alice to the outside world. So in order to prove that, I'd recommend you use a site thunderdice.ws. And this is just a little bit of gambling using testnet funds. So we're going to use Thunder Dice. So hit Let's Roll, select the last game just so you can guarantee it will actually work, and then just reduce the wager amount. So what this is asking us for now is we're betting an amount, but if we win, they need somewhere to send the money back to. So because we're going to use Charlie for this to prove the full end-to-end linkage, Charlie needs to create an invoice that will be paid only if he wins the bet. So we'll just copy what they've asked us to create the invoice for, paste that in. So in the background, it's now generated its own invoice for the initial bet, the initial funding of the bet. So what we'll do is copy that invoice, and from Charlie, we'll then send a payment. Now bear in mind, Charlie is not connected to the faucet, the outside world. So what it should do is go from Charlie to Bob, Bob to Alice, Alice to the faucet, and then find a route to the Thunder Dice guys. And that's what we see here. So each paragraph of text is an extra hop. So this first one is from Charlie to Bob. which is the 800,000 we set, then a million and a million. And then as we come down, you can actually see that this is when we start to leave our network, jump to the faucet, and then the faucet finds us a route to the final destination. And we can see the payout is now pending on the site, so it has completed. There is an error sending the payment back to us, and I think that's because the command I used when creating the payout invoice was incorrect. But you can try it yourself and it should work as expected. And of course there are alternatives such as star blocks, which you can use to prove from your own nodes right the way out to the internet and back again. So that's it. That's a full end-to-end setup of LND Lightning nodes in Ubuntu, testing them both internally and externally. I hope this was useful. The next step really is to start looking at some of the web interfaces. So rather than using command line, you can just use a web interface. If anybody's interested in a video to set up that and use that, then please let me know. Other than that, thank you very much for everyone's time. Cheers. Bye.